Let's go ahead and get started in this review. I know that you guys don't have calculators of your own quite yet, so I'm going to show you how to get the zeros on this particular problem because it's a little bit odd from what you're used to. So let's start with doing the zero. So normally it's taking the numerator and setting it equal to 0, but remember this one is a reciprocal function and the zeros are a little different. So what you would do is type this thing in the calculator first, and when you do that, what you get is a graph that looks like this. So from here, we need to do second trace, and we need to calculate the zero. So we're going to go to number 2. Left bound means we need to be on the left-hand side of our x-intercept, which would be here. So push enter, and then we'll scroll over to the right-hand side and push enter, and then push enter one more time. So you'll see that the 0 is at 1/2, comma, 0. So let's go ahead and write that in then for this problem, 1/2 or 0.5, it doesn't matter how you write it. And so again, this is all because the fact that it's a reciprocal function, so I know when you're doing this on your own, these ones won't be so easy. And that's okay, I'm not all that concerned about those ones in particular because you will have a calculator in class. All right, now your y-intercept. I'm going to go ahead and do the work down here. Y-intercept is plugging in 0 for x. So we get -7 over 0 minus 4, and then a -2 afterwards. So what that comes out to be is a -7 over a -4, and then you subtract 2 from that. Negative over a negative is a positive. And when you do 7 over 4 and subtract 2, you get a -1/4. That's not a 4, that's a 2. All right, -1/4. So our y-intercept is 0, comma, -1/4. All right, so vertical asymptote we get from taking our denominator and setting it equal to 0. So we take our x minus 4, set it equal to 0. So we get x equals +4. And then our horizontal asymptote. Remember with reciprocal functions, so this one is reciprocal, and that's all because there's only a variable in your denominator. We use this -2, the number that's after the fraction. So y equals -2. So just to remind you, number after fraction. All right, so y equals -2. Okay, so let's go ahead and get our graph on here then. Our vertical asymptote is at x equals 4, so that would be here. And we do vertical line. This is really hard to do with this slate thing that I'm using, so I apologize. It's not looking all that pretty. All right, and then y equals -2 is the horizontal. Then we need to go ahead and make our graph. Well, if the y-intercept is at a -1/4, that happens right here, right? Just barely below the x-axis. And so what we then do is curve up and over this way. And then we go ahead and reflect that onto the other side. And again, that's because it is a reciprocal function that it just reflects. So our domain, we need to put in both set building and in interval. So x such that x does not equal 4. And so that would be from -infinity to a +4, union 4 to infinity. And then the range would be f of x. I'm going to go ahead and use that. So f of x such that f of x does not equal a -2 coming from the horizontal asymptote. And so that would be a -infinity to a -2, union -2 to infinity. So there's your graph for the very first one. And so you'll repeat that. The zeros on your other graphs, the only one that would have is number 2, and it's a little weird. So that's okay. You don't have to really worry too much about that, as long as you can do it on the calculator. Okay, so the next one I decided to do for you is number 5, and that's just because it's a subtraction problem and you have some factoring. So we need to factor and we need to get a common denominator. So let's go ahead and start with our factoring. Both numerators are only one term, so we don't really have anything to do there. But this n squared minus 9 does need to be factored. They are both perfect squares, so it would be n plus 3 and n minus 3 in that first denominator. And what we're subtracting is 3 times n plus 3, which cannot be factored. So basically, if we're looking at our denominators, all that needs to happen is this fraction right here needs an n minus 3. So we just take one piece of everything, right? So n plus 3, n minus 3. And remember that this is what you want your denominator to be. So this one is good to go. It already has everything we need. This one does not. So we need to make that happen. So we are going to take our, I'm going to box this off a little over here so we can separate our problem. So I'm going to take this 6n over n plus 3 times n minus 3 minus 3 over n plus 3. All right, so this one, I didn't do anything to it because it already has both pieces of the denominator that we want. However, on the other side, this does not have an n minus 3. And since it doesn't have an n minus 3, we're going to give it one. So remember, we can only build up, we can't take things away. So this first fraction still has not changed. So it's still 6n and then n plus 3, n minus 3. And then from that, what we're going to do is subtract 3 times n minus 3 over n plus 3 times n minus 3. Now that the denominators match and we're subtracting, we can write it as one big fraction. So 6n minus 3 times n minus 3 over n plus 3 times n minus 3. And then we need to distribute here, and we're distributing a negative 3. So we get 6n minus 3n plus 9 over n plus 3 times n minus 3, which then as we go just a little bit further, we get 3n plus 9 over n plus 3 times n minus 3. And now this one I'm actually going to go a little bit further, only because 3n plus 9 is divisible by 3. So if you factor 3 out, you're left with n plus 3 afterwards. And the reason that I did that is because what we can now do is cancel out a common factor from the numerator and the denominator, and that would be your n plus 3 that cancels out. So your final answer would be 3 over n minus 3, and there we go. Okay, so common denominator, and from there it's just simplifying. All right, the next problem we'll do is number 6. So in number 6 we have division, and remember division means that to multiply by the reciprocal. So we need to keep, we need to change to multiplication, and then we need to flip our second fraction. And so when we do that, remember keep means keep your first fraction exactly as is. So I'm not changing anything to it, leaving it. Changing to multiplication, and you only do this when it's division, and then you flip your second fraction so that now your denominator is your numerator and vice versa. So now it's 14x squared, y to the 4th over 72, c to the 8th, d. So from here what we need to do then is just multiply straight across. So remember, anytime it's multiplying, we go straight across. Now this is only one term in the denominator, so there's no factoring. So one term equals no factoring, just as a reminder. And so because there's no factoring to do, and remember the one term means there's no plus or minus signs. Okay, so that's how we determine how many terms there are. So multiplying straight across, I'm going to go ahead and do this here. Up top, 36 times 14 is 504, so 504. And then all I'm going to do from here is just c squared times d to the 4th times x squared times y to the 4th over. Now down here, 70 times 72 is 5040. And now what I'm going to do on the bottom is put the letters in the same order as they are up top, because any multiplication is commutative, so you can move things around however you want. It doesn't matter. So I'm going to put c to the 8th first, so that way it lines up with c here. And then I'm going to put d, then x cubed and y squared. So now from here we need to simplify. And remember that you can use your calculator to simplify any fractions. So 504 over 5,040. So I'm going to go ahead and do 504 divided by 5,040. Math, enter, enter. So 1 over 10. So I'm going to go ahead then and write this as 1 over 10. All right, now we need to look at our c squared over c to the 8th. Remember, you subtract and always put it where the higher exponent is, so that would be c to the 6th. D to the 4th over d, so 4 minus a 1 here would be d cubed. X squared over x to the 3rd, subtract them, 3 minus 2 is 1, so this is x to the 1st, and then y to the 4th over y squared, subtract, would be y squared up here. And all I'm going to do from this point is just take away the 1 because we don't need it, so d cubed y squared over 10c to the 6th x, and I'm not going to write a first power on that, I'm just going to leave it as it is. Okay? And moving on to number 12. So doing our zeros here, take your numerator, 2x plus 1, and set it equal to 0. And this one is called a rational function. So this one is rational. And again, that is because there are variables here and here, so numerator and denominator. So when we set that equal to 0 and go ahead and solve it, we end up getting negative 1/2 for our x. So negative 1/2, comma 0. Y-intercept is plugging 0 in, so 2 times 0 plus 1 over 3 times 0 minus 2. So this is h of 0. So what that gives us then is a negative 1/2 here as well. So 0, comma, negative 1/2. Vertical asymptote is taking your denominator and setting it equal to 0. So 3x minus 2 equals 0. When you solve that, you add 2 to both sides to get 3x equals 2. Divide by 3, and you get x is 2 2/3. So x equals 2/3. Horizontal asymptote, now this one has to do with the degrees because it's rational. So when we're looking at our degree, the degree of the numerator is 1. The degree of the denominator is also 1. So when they have equal degrees, you take leading coefficient over leading coefficient. In this case, that would be 2 over 3. So you get y equals 2/3. Now it is coincidental that it happens to be 2/3 here and 2/3 here. That's not, it doesn't happen all the time. It just is for this particular problem. Point discontinuity is common factors, which we didn't have any, so there were none. And that came from the fact that we didn't need to factor here. There was no factoring to do. Okay, they didn't have anything in common. So no factoring needed. Go ahead and write that. All right, so your vertical asymptote is at x equals 2/3. So we're just going to estimate here and just kind of draw our line. It's not really all that perfect and wonderful, but it's all good. And then y equals 2/3, same thing. It's not going to be right on a line. All right, there we go. Our y-intercept happens at a negative 1/2, which is here. So that means this portion of the graph is going to happen on this side, and then this curves up this way as well. And this one should not come back out. That's just because of the pen. So don't make that happen. And then to find out where the other piece of the graph needs to go, you need to plug in a value. And so something like 2, and see what you get out. And if you plug in 2, you end up getting 5 over 4, which is just over 1. So it ends up here. So that gives you your graph on this side as well. And there you go. So your domain would be x such that x does not equal 2/3. So that would be negative infinity to 2/3 union 2/3 to infinity. And then your range would be h of x such that h of x does not equal 2/3, and then also negative infinity to 2/3 union 2/3 to infinity.